Our next speaker is from BP, Cristiano de Cruz, a machine learning researcher. And Cristiano today is going to be presenting on causal AI applications at BP, giving us a glimpse into how this technology is shaping the future of energy. Welcome, Cristiano.
Okay, I should first check. Can everyone hear me okay? Okay, I will try not to wander away from the lectern or I'll get some evil eyes from down over here. So my name is Cristiano, and I'm going to talk a little bit about the way that we're thinking about using causal AI in BP today. So for a bit of background as to who BP are, we provide energy to businesses and people around the world in a way that is safe and secure. And as we transition away from being an international oil company to an integrated energy company, technology is a key enabler, and that's kind of one thing that my research and development team is specifically investigating. So we explore technologies such as causal AI that could really revolutionize BP and the energy industry as a whole. So today I'm going to share some early insights and thinking that my team has, and hopefully gives you a better understanding of the use of causal AI in a completely new industry. So to start off, causal AI isn't new to us. So there's this kind of common misconception that suddenly we're all going to be looking at it just this year. But we've been analyzing causal since 2019, and as you probably know from the other talks today, causal has been around for much, much longer than that. But why is it actually such a big topic for us today? And so the reason first is the limits of artificial intelligence. I'm sure all of you have been to plenty LLM RAG conferences in the last year, so you're aware of some of these, but I'll quickly talk through them. The first big limit is explainability. So I think Darko in his very first talk talked about trust. Without explainability, we don't have trust in the different models that we are building. And that becomes a really big issue when we take some of these really cool and exciting models, show it to the business, and they say, I can do it better. So then that kind of makes my team very sad, but makes it difficult to integrate digital as an enabler. The next thing is moving from agents to action. We can build these really advanced, really fantastic models that are able to perform incredibly well, but then we need to go away from just insights and then take this to a business and turn these into actions that our business can take. And as you've seen through, I'm sure, many of the examples today, it's not always easy to move from insights to action. And finally, multitasking. So again, these models tend to be very narrow. I know some people like the term narrow AI, but I like to think about kind of how do we move away from narrow AI into these different models that are able to communicate with each other and actually solve some of these complex business problems that can't really be solved by just one machine learning model or one artificial intelligence algorithm by itself. Now, just to contextualize this presentation, my team does do technology-first research and development, but when we work in a bigger organization, the value case is super important. So it's not just the fact that causal AI is a really interesting technology that we think we need to pursue as we head towards more advanced AI in the future. We believe that there is core value for this technology in our business today. And that's the reason that we're here and talking about some of these use cases. Now, luckily, I follow a very technical talk, so I don't need to go into too much detail about all the different types of causal modeling that exists at the moment. But I will share with you this kind of framework. I stole it from ChatGPT, so feel free to kind of steal it as well. And it's something that I use to frame lots of the workshops that we do with different parts of the business. So we collect lots and lots of rich data. Because we've got these industrial processes that have been running for kind of nearly hundreds of years, we are able to collect significant amounts of data, which means that we can turn this data into insights really effectively with standard artificial intelligence or standard machine learning. Where the struggle comes now is how we move away from insights and turn those insights into actions. This is the automated decision making. What causal AI brings to us is the ability to take all this complex data, to then work out kind of how that data is structured in a certain way, and then actually tell us what decisions we need to make. This has significant value to us because we can then take some of these digital systems and scale them across our operations, which again are worldwide. And here I just share one quick example of a fluid catalytic cracker. So what that means is we have a long chain of hydrocarbons. We collect data throughout this entire process, so temperature, pressure, how much of the different feeds are going into this different process, and we want to calculate how much burned coke do we get out of that. So this massive hydrocarbon chain gets broken down, and then we're trying to identify what are the different factors that actually cause a certain mass of coke to be produced. And then that correlates directly, correlates not causates, but we know from expert knowledge that it is causation, the amount of energy that can come out of this process. I'd also recommend, by the way, looking through this paper because it gives a really good literature overview of some of the different causal AI methods that have been tested across our industry. But this is just kind of one example that I've picked out. And these causal graphs are really critical to companies like BP. So they're critical for us to understand the vast amounts of data that we have coming through. So lots of the use cases are kind of based around this. But I will talk through kind of some of the different questions that we try to answer, both in kind of the oil and gas industry, but then also as we transition and what kind of causal AI looks like on that front. So a couple of different use cases within oil and gas. Before I talk about these in loads and loads of detail, I just wanted to highlight something that you might not know, and that is these processes are incredibly dangerous. So when you are going around and you actually see the way that some of our platforms operate, people are put at risk, and that is because the pressures are incredibly high, the temperature of the fluids can be incredibly high. So we need to make sure that all the decisions that we make on these platforms and across our processes are going to kind of reinforce human safety. So if we make a bad decision, that can cost lives. Okay, so this is kind of why causal AI is going to be a critical enabler, especially within kind of the oil and gas sector. So there are a couple of kind of key questions that we would ask with causal at the moment. The first thing is maximizing yield. So all these different complex processes, so they always start as something that's quite simple, kind of a simple pipeline or a simple flow. And then we start to add in various control loops. So if the pressure over here is a little bit too high, then I need to decrease the pressure down here, then I need to change the temperature somewhere else, I need to change the flow rates in different places. And before you know it, we're looking at diagrams that are kind of pages and pages long which articulate one simple flow from one place to another. So trying to do any optimization around that is incredibly difficult for human operators and for the field operators themselves. The next thing we also look at is what actions can we take right now? So this is kind of the actual doing. And kind of the example I gave here was energy reduction. So of course, all our operations need to sustain their own energy. So if we're able to use causal inference to determine exactly how can we reduce the amount of energy in these complex systems, that can have a huge impact on our operations. And finally is root cause analyses. So I mean, root causes kind of permeate throughout our entire business. And I'm sure that all of you can think of plenty of root cause analyses that you'd need within your own businesses as well. But especially when there's intermittent energy disruption. So when there is energy disruption, this affects anyone that relies on the energy that we're producing. And this can have a global impact. So making sure that we have an accurate technology like causal inference that is able to answer these questions for us is critical for our operations and critical for all our customers. But it's not just oil and gas. So there are lots of newer spaces within energy that we're going to be exploring how causal AI can come in and influence us. So firstly is policymakers. So when a new policy is implemented, there's lots of decisions are made in order to understand the way that a consumer might behave. But especially policy that affects energy, which again is all of us in this room, we will be able to track and make sure that any policy that we influence in the future is going to have the desired effect on kind of the industry that we're in. But you also want to try and analyze and improve customer behavior. We want to encourage our customers to be more sustainable. And if we can build these graphs, which then map out the way that customers make decisions, we can almost go backwards through the causal process and influence the way that they make those decisions and encourage people to be more sustainable. Also, in terms of understanding long-term grid investment, so if we want to make decisions about what do we invest in today that will improve sustainability in the future, we can run these two different scenarios through some causal models. And finally, quantifying environmental impacts. So lots of the builds that we have are going to have an impact on biodiversity around us. So it is incredibly important for us to be able to we use all our sensor data to then understand exactly the impact that we're having on all these different populations, biodiversity, kind of that we're operating within. I also did say to the organizers, I'm going to go a little bit off piste here and kind of go a bit beyond causal AI, because causal AI is not the only technology that kind of we're interested in, but we believe that it's a gateway to other technologies that will also influence our industry. And the first one I'll talk about is explainable AI. Now, I'm sure that you would have all come across this in some way, shape, or form. There are many different types of explainable AI. But this goes back to the point I made on the very first slide, which is we need to have models that we can understand that are going to be trusted, not only for business adoption, but also for the regulators, for the people that come in and inspect our processes to understand the way that we are operating. So higher trust in these different models allows us to engage with our stakeholders better. The second thing is multi-agent, so having different AI agents or even robotics, which is another area of focus for our team. With robotics, we're then able to understand the causal structure of the environments that we're in, but we can also get two different agents to start to understand the causal decisions that each other are making. So the same way that kind of me as a human can understand kind of the decisions that I make in a conversation, we want to get robots to do that autonomously. So explainable AI is kind of the next step away from causal, and that's what's going to enable us to interact with robotic agents or AI agents more effectively. But once we have multi-agent systems, we unlock this robot-to-robot collaboration, which is critical for the future of energy. And I'm guessing lots of you are here because you saw advanced wind farm, and that sounded really exciting. So I will move on to the advanced wind farm. And kind of this is one space where we will see kind of robotics playing a key role. So at the moment, kind of the critical use case you will all have heard of is routine maintenance. If I know something is going to go wrong, every couple of years, let's say 5 years, I might then send out an engineer to go and inspect that. They will log in what they found. Eventually, the site is going to go down. That's a whole emergency procedure. That is an okay process. It's something that we've tried and tested. But what causal AI gives us is the ability to predict when we need to do maintenance very effectively. So we can build some of these causal graphs which understand how each component is going to be affected by, let's say, wind speed, affected by temperature, and we can use that to determine exactly when a component is going to fail. And this is a combination, again, of causal and standard machine learning. But ultimately, we don't want to put a human up there doing this incredibly dangerous operation. So if we were able to get robotics that could come in and do some of this inspection, do some of this maintenance autonomously, we're then able to remove a human from dangerous operation. We're then able to probably operate more efficiently, more effectively, because there isn't someone that's afraid of something happening to them while they're up there. And then we're also able to collect a lot more data from that process as well. So there are significantly more benefits for having these robotic systems. And this all starts with causal AI. So this is why today we are experimenting with causal AI to determine kind of what different proof points, what various use cases, like the ones you've seen today, yield significant value for us. And then this will lead us to hopefully some of these advanced kind of explainable and advanced multi-agent systems that we will need in the future of energy. So thank you very much.
Thank you, Cristiano. Couple of questions come in. I'm sure there's more as we put the sign up there. So what are your thoughts on the green credentials of AI overall? And I think it's where we know training LLMs is taking increasing amounts of energy to complete and then run. Are you almost like counter to the energy crisis?
Yeah, so it's one thing that our team is actually looking at effectively is how can we run, well, it's not just AI, but even things like blockchain, which have been incredibly energy intensive in the past and also water intensive, by the way. So you'll see lots of research in that space. So our team is looking at ways that we can build AI agents that are able to run kind of in more energy efficient ways. Whether there's a space for causal AI specifically there, it would be interesting to explore.
There's a right answer to that,
Yeah.
Anyway, okay. Given you mentioned earlier some of the BP projects are looking at reducing energy usage, are you looking at how you can share that knowledge and experience to help all organisations reduce energy usage? I don't know how transferable that would be.
Yeah, so our team specifically, we work a lot with universities, we work a lot with startups, and we also take part in many symposiums. So there are loads of energy symposiums across different use cases. You might have heard of things like the High Value Manufacturing Catapult in the UK. That is something that we look at. But But there are so many groups where we try to bring some of the knowledge that we have on the processes to ensure that we bring this global level of safety to all the energy operations, including that of the other people that we work with. So, yes.
I don't know where this question came from. It says, how do you plot causal graphs in the absence of causaLens and tools like that? Just say, it's a lot easier with causaLens. Again, there's a right answer, but anyway.
Yeah. So we will be exploring causaLens. So we do work with causaLens, and we're talking about some of these use cases with them, because it's really important that we bring along experts in the technology. So the way that our team works is we try to identify the different expertise. We've got our own internal team of experts, and then we find spaces across our operations that we can deliver some of these POCs. So I hope that one day in the next couple of years, we'll be able to share with you some of the results of some of the POCs that we're going to be looking at in the causal space. But that's something that we have to wait for time to tell.
So we have got through the questions, but there's one from me, if that's all right. And I'm just interested, how does the rest of PP receive the sort of advanced technology team and ideas and things there? Because, as you say, it's an industry that's been around quite a long time. So how do you go about convincing people that these are the right sorts of things to be looking at?
Yeah, so well, across the company, digital is a core part of our strategy. So different members of BP across the different businesses are encouraged to adopt some of these newer methods. It can be difficult when we have to convince people of that business value itself. But we believe there are some people that are incredibly kind of tech. So they're tech enthusiasts. They love to work with us. They love hearing all our crazy ideas as well as the practical ones. But it's about engaging with the right people, being able to convince them of the business benefit. And this is something that Causal is really going to help us with, because if we can use that level of explainability that comes with Causal AI, it will help us scale out some of these kind of advanced AI technologies a little bit more effectively through our business.
I said it was last. There's another question come through. We've got just enough time. How do you quantify the risk and danger versus the easily quantifiable increase in energy yield? So,
Yeah. So again, because safety is such a key part of our strategy, it's something that we just do not compromise on. So if an operation is unsafe, we will do whatever we can, whether that's digital or otherwise, to try and make that operation safe for a human to operate in. So yeah, that's kind of not a question that it's not a case of balancing. It is safety is just a core principle of our company.
And then I will finish on this one because I'm now looking at the clock. How do you prioritize between use cases that deliver value now versus long-term investments that won't pay off immediately?
That feels like the million-dollar question that I can throw to absolutely anyone in the room. I think both types of innovation are needed. We've got different expertise in our team. I wish there was a right answer. If there was a right answer, I would share it with you. But it is a case of determining what we're able to create value with immediately versus kind of what's going to have these kind of longer-term impacts in the future. We know with the longer term, it's difficult to quantify what that impact is going to look like. It's just something we're mindful of, but that doesn't mean we shouldn't try. So kind of a bit of both. Yeah.
And with that, thank you. Thank you, Cristiano.